Okay, these are 4 questions from 8.2. So if you're practicing at home because you're studying for your test, you want to make sure you can isolate variables in 2-step equations that involve fractions or decimals. These are 4 good practice questions to see if you can do. So if you're doing it at home right now, write down these questions. You can do it one at a time. Press pause, do the question, unpause, listen to my answer, and see if you did the same thing I did. So the first question says a half plus 3/4 of x equals 1/5. So the first thing you have to be able to do is identify what is your constant in this equation. In this case, it's a half. So you have 2 options. Of course, you can multiply both sides by a common multiple of the denominators. Did anyone in the room multiply both sides by 20? Not one person. Did everybody in the room subtract 1/2 from both sides? Okay, 2 people. So, all right, interesting. So I'm going to do it the way that the majority of you probably did, is to subtract 1/5 and 1/2 from both sides. So then you have 3/4 of a number equals whatever 1/5 take away a half is. Common denominator, equivalent fractions. 2/10 take away 5/10 is -3/10. So I'm going to write that down as -3/10. Now the next thing I'm going to do is get rid of my multiplier, which is 3/4, and I'm going to divide both sides by 3/4. That's going to get rid of it. I'm going to be left with x. But dividing by 3/4 over here, I know is going to be multiplying by the reciprocal, which is 4/3. So instead of physically writing down, all right, so now that we have -3/10 multiplied by 3/4, probably I'm going to cross reduce. -3/3 would be a -1/1, same thing. 4/10 would be 2/5. And now that I have that written down, 1 times 2 is -2, 5 times 1 is 5. The answer for x would be -2/5. Now obviously if you didn't cross reduce, you got -12/30. You got -12/30 if you didn't cross reduce. But of course you would have to reduce that to lowest terms. 6 is a common multiple. You still would have gotten -2/5 even if you didn't cross reduce. Okay? So the answer is x equals -2/5. Now, I know this is cumbersome and I know this is going to take a long time, but I'm going to go back in time and I'm going to solve it a different way. So if you're not quite comfortable with multiplying by a common multiple, I'm going to show you real quick how multiplying both sides by a common multiple of all the denominators. So the denominator in the first term is 2. The denominator in the second term is 4. The denominator in the third term is 5. If you were to extend this to find all of the common multiples of all the denominators, you would find that the first one they shared would be the number 20. Okay? You could also get that just by looking at 2, 4, and 5 and think about, what is the number that they all share. 20 would work. 40 would work as well if you couldn't do it. And because if you just multiplied 2, 4, and 5 together to get 40, 40 will still work if you're not sure about what the lowest common multiple is of the common. So I'm going to multiply this side by 20, and I'm going to multiply this side by 20. And like we said in the last question, if you multiply both sides in an algebraic equation by a common multiple, as long as you multiply every term in that side, you maintain equality. Here you're going to require distributive property. For those of you who are a little bit weak, I'd write out each of these individually. So 20 multiplied by a half. I go 20 multiplied by 3/4 x. Now here, 3/4 multiplied by x is the same thing as 3/4 multiplied by x/1. Multiply the numerators, you get 3x. Multiply the denominators, you get 4. So 3/4 of x, it's important that you see it as also being 3x/4. That's an important kind of step that's a little confusing, but helpful at this particular point right here. So if you rewrite that as that, it makes a lot more sense. And then 1/5 multiplied by 20/1. This is going to end up being 10/1, which is 10. So 20 multiplied by a half is 10. Cross reduce here, you get 5. Now 5 multiplied by 3x, that's just a monomial times a monomial. That's going to be 15x. And when you cross reduce here, you're going to get 1 times 4, which is 4. So the reason why that's important, I know it looks confusing because there's a lot of numbers and cross reduction and scratching things out and all that kind of jazz. But when you do all that stuff by multiplying both sides by 20, you create a much simpler equation that you can solve, and you don't have to worry about fraction sense at all. Subtract 10 from both sides, You get 15x equals negative 6. Divide both sides by 15. And x equals negative 6/15, which in lowest terms, because both are divisible by 3, would be negative 2. What did I say I was dividing by? 5. Negative 2/5. Is that what I had in the last answer? Yeah, negative 2/5. Okay. There. That's how you can do it either way. Now, the other three questions, questions 2 and 4, are pretty darn simple because they involve decimals. And if you have a calculator, or even if you don't, you can still probably do it without it. Get rid of your constant by adding that. 1.7 and 3.8 you can do in your head. That's $1.70 plus $3.80, which is $5.50 or 5.5. Now remember, we said this in the story problems questions. When you divide by a tenth, which is what 0.1 is. When you divide by a tenth, it's the same thing as multiplying by the reciprocal. So dividing by a tenth is the same thing as multiplying by 10. So I could probably solve that without going to a calculator. I can do this if I understand that without a calculator, because 5.5 times 10 is 55. But if you grab your calculator and go, what is 5.5 divided by a tenth? It'll still tell you 55. Because if you understand dividing by a tenth is the same thing as multiplying by 10, Bob's your uncle. Now the third question is fractions again. If you were to multiply both sides by a number, the number you would choose, because 2 over 1 is really 2 is really the fraction 2 over 1, you could multiply both sides by 10. And if not, you could just add 3/5 to both sides. So I'm going to just do it the old-fashioned way and add 3/5 to both sides. I'm going to add 3/5 to both sides. That's going to make a zero pair. This is going to be 3 over 2x. I'm going to change my mixed fractions to improper. Equals, that's not as hard as you think it is, because 2 plus 3/5 is really 2 3/5, right? That's easy. Or as an improper fraction, it's 13/5. Now that you have that written down, you're going to divide both sides by the multiplier. So you're going to divide this side by 3 over 2 to get rid of multiply by 3 over 2. And when you divide by 3 over 2, it's the same thing as multiplying by the reciprocal. X will equal the product of those. Look for cross reduction. Hey, you can't cross reduce. That's interesting. Which means that 26 over 15 is your answer in lowest terms because you couldn't cross reduce, which is the same thing as 1 and 11/15. And finally, in your last question, you have both decimals and fractions. So the reason why I gave you this question is when you're confronted with a question that has both, choose one or the other. Most smart people will choose decimals because it's much easier. So I'm going to rewrite this question before I even solve it or isolate it. I'm going to change 1/5 to a decimal. 1/5 is 2/10, which is decimal 2. And by the way, if you didn't know how to change 1/5 to a decimal, just take 1, divided it by 5, and it'll tell you it's 2/10. Now I have a question that's all decimals. I'm going to subtract 2/10 from both sides. I'm going to 0.7x equals $3.40, take away 20 cents, which is $3.20. Divide both sides by 7/10. Remember, dividing by 7/10 is the same thing as multiplying by the reciprocal. Ooh, that doesn't help me. Don't care about that then. But 3.2 divided by 7/10 is, holy snap burgers, x equals, let's see if we can figure out what the repeating pattern is. 571428. 571428. 571428. 571428. So it's 4.572418. Is that what it was? Close? Who cares? Well, I don't really care. You put a bar above that whole 6-digit sequence because that 6-digit sequence will repeat to infinity. Okay? And that is your answer. Now here's another interesting thing. If you want to figure out what that is as a fraction, so really what I did was this. That gave me my decimal. And since that, if I multiplied by 10 and multiplied it by 10, would be this, right? Are you with me? Everyone following me along? This is an improper fraction. So therefore, x is also equal to 5. No, it's not. 4. Because how many 7s in 32? 4, that's 28. With 4 remaining. So you watch this. If I go 4 and 4/7, and ask a computer, what is 4 divided by 7? Boom, shakalak, same decimal. 42, oh, son of a goat herder, 142. So 57142. So 57142.8. There we go. Does that make sense to everybody? This decimal that I divided to get this answer right here is really equivalent to this equivalent fraction, which I can then reconstitute back to a mixed fraction if I really want to.